Hello, and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of modeling the Pythagorean Theorem. This is standard 8.6c in the great state of Texas, and we are using item number 19 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. We've got a right triangle, and it's got 3 squares. And you notice that these 3 squares are actually joined at the vertices here. So, which of these statements is true? Well, we need to go back to what we know about the Pythagorean Theorem. And this actually is a visual representation of what that means. So most of us are familiar with this, even if we can't necessarily explain it. Because we've heard someone say, a squared plus b squared equals c squared. So what does that mean? Well, this works with a right triangle, like we've got right down here in our picture. And so a right triangle always has, obviously, a right angle. And the side that's directly across from the right angle is called the hypotenuse. And when we are looking at this Pythagorean theorem, what we're naming this hypotenuse is c. So it's always represented by the letter c. And then you've just got 2 legs. It doesn't matter which one is which. So 3 sides of a right triangle are called leg, leg. And we're not really differentiating them except that we've got 2 different letters here. We'll call this one A, we'll call this one B. So we can kind of transfer that over here. A, B, C. It doesn't matter if we swap the A and the B, like they can be swapped, that's easy. What we can't do, though, is name the hypotenuse anything other than C, simply because what was discovered by Pythagoras so many thousands of years ago was this right here, a squared plus b squared equals c squared. So let's take this a right here, and then let's square it. Literally, that means make a square, because if you square it, right, you're going to multiply a times itself. Well, and that's how you find the area of a square, right, is side times side. So if you literally build a square right here, that's a squared, right? A times a. And that's the area of this square right there. And then you got b squared. And these are different side lengths, which is fine. So you got b squared. And so the area of a square is going to be a squared. And you can also do the area of a square is also going to be b squared, depending on which square you're looking at. Because you're doing side length times the side length. B times b, a times a. What Pythagorean theorem does is it says if you take this area right here and you add it, if you put numbers here and you add it to this area right here, the a squared plus b squared, the 2 areas, you will actually get the exact area of this right here, the c squared. And it doesn't matter the size of the right triangle. If we were to put numbers in here, what we would find would be, like, let's say this is 3. Okay, so let's say this a is 3, right? And let's say that b is 4. So this would be a squared would be 9, b squared would be 16, so c squared, that would be 5. And that would equal 25. Doesn't matter the side lengths, it always works. That's the Pythagorean theorem. Now, which of these statements says exactly that? The sum of the areas of n plus L, so n plus L, is equal to the area of k. Well, they just try to trick you because they use n and L and k, but if we were to label these a squared, right, a squared is n, b squared is L, and k is c squared. Yeah, that looks good. The sum of n and L is greater than the area. Nope, it's not greater, it's equal. The sum of the areas of n and k, okay, look at this. Now it's saying n and k. So that's a squared plus c squared equals b squared. Now we're saying less than. Actually, those two are greater than L. So D could have been correct if it was greater than L. But our answer is A.